Welcome to Professor Guna Explains AI podcast. Hey everyone, I'm Professor Guna Wardena, and today we're diving into a fascinating topic in AI, classification. Now, what's classification all about? Well, at its core, it's how AI learns to categorize and label data, making sense of the world around us. And trust me, this technology is doing some pretty incredible things, like helping doctors detect cancer earlier and even reshaping the future of healthcare. So, stick around. We're breaking it all down, from the basics to the big real world impact. Let's get started. But I'm not tackling this topic alone. Today, I'm joined by my AI buddy, Jessica.
Thanks, Professor Guna. I'm excited to be here. Classification sounds like a powerful tool in AI, and I can't wait to explore how it works and why it's making such a big impact.
Exactly. And at its core, classification is really about pattern recognition on a massive scale. Take this fascinating study from Wisconsin back in the 1990s. Researchers collected data from breast cancer patients, analyzing 30 different features of cells to determine whether they were cancerous or not. And by using this data, we can actually train a computer to recognize those patterns, essentially turning it into a kind of medical expert. The beauty of AI here is that it can process massive amounts of information at lightning speed, far beyond what any human could manage.
So, um, it's kind of like teaching someone to identify ripe avocados, but instead of color and softness, we're looking at other characteristics to determine their ripeness, right?
Exactly. Now, imagine teaching a machine to classify human cells, not just looking at them the way a doctor would, but analyzing precise features like cell radius, texture, perimeter measurements, and even concavity, which describes the shape of the cell.
That's just the start. There can be hundreds of different features that AI can analyze, each providing crucial clues about whether a cell is cancerous or not. And if we can train a machine to recognize these patterns accurately and do it faster than any human ever could, we're talking about a revolutionary change in how diseases like cancer are detected and diagnosed. Right?
You got it. That's where AI really shines. While we humans can only visualize two or maybe three dimensions at once, AI can work with hundreds of features, sometimes even thousands, all at the same time to make predictions.
That's incredible. But, I can't help but wonder about the accuracy. I mean, we're talking about cancer diagnosis here. How do they ensure the AI doesn't make mistakes?
Great question, Jessica. That's where the concept of the gray area comes in. Instead of forcing every case into a yes or no decision, the AI can essentially say, I'm not confident enough about this one. They create a buffer zone where additional testing or human expertise is definitely needed. It's a crucial safety feature in medical applications.
Oh, that's really smart. So it's not about replacing doctors, but giving them a powerful tool to work with?
Precisely. The AI acts as a sophisticated screening tool that can process vast amounts of data quickly, but the final decisions still rely on human judgment and expertise. Think of it as giving doctors a highly advanced microscope. It enhances their ability to see patterns, but doesn't replace their critical thinking and experience.
You know, this reminds me of how our phones can now automatically sort photos of cats and dogs. Is it the same basic principle at work?
Absolutely. It's a perfect analogy. And that's why classification is such a powerful tool. It's everywhere. From your phone unlocking with facial recognition to spam filters, keeping junk out of your inbox, AI classification is working behind the scenes to make sense of the world. So, how does an AI actually learn these patterns? What algorithms power this process? That's what we're diving into next.
I cannot wait to hear that. To me, all this seems like a black box. How is it possible for AI to do all these things so efficiently?
Let me break it down in simple terms. Imagine you want AI to classify a liquid into the right category. To do this, it looks at three key features: carbonation, sugar content, and acidity. Now, let's start with carbonation. Both water and lemonade have zero carbonation, so AI can't rely on that feature alone to tell them apart. But what if we add sugar content as another feature? Water has zero sugar, while lemonade has some sugar. With this extra information, the AI can now correctly classify water and lemonade. We can take this further by adding acidity to the equation. Now, we might even add sparkling water to the mix. There is endless potential to automatically classify objects. That is what classification does.
I get it. So, by adding more features, or dimensions, AI becomes better at distinguishing between different liquids, just like how humans use multiple clues to recognize things more accurately. That's fascinating. I also have another question, Professor Guna. So, what would you say to someone who feels intimidated by all this technology? How can regular people start to understand AI and engage with it?
Yes, that is a good question, and one we want to address through this podcast and a series of video courses. If we want to apply AI to our work, we need to learn the first principles of AI, such as classification. So when you see a new problem, you are able to say, aha, I know this is a classification problem.
I get it. Understanding that classification is all about recognizing patterns and features makes the whole process much clearer. You don't have to be a mathematician to see that if something shares key characteristics with known examples, it's likely to belong to the same category. It's just like how we naturally learn to recognize faces or voices, by picking up on familiar details and matching them to what we've seen or heard before.
Yes, Jessica, that's a helpful way to think about it. If we are willing to learn and apply these ideas to our work, AI not about replacing human intelligence, but about extending our natural abilities to solve bigger problems. Isn't that exciting?
Exactly. That's why understanding classification is becoming just as essential today as basic computer literacy was a generation ago. Whether you're a doctor, a business owner, or simply navigating the technology around you, knowing how classification works empowers you to make better decisions and use these tools more effectively. So, Professor Guna, what are some exciting future applications of this technology that we might not have even imagined yet?
Oh, the possibilities are endless. We're already seeing classification play a huge role in environmental monitoring, helping detect early signs of natural disasters, identifying new astronomical phenomena, and even aiding in wildlife conservation by analyzing animal photos to track endangered species. But perhaps the most exciting applications are the ones we haven't even imagined yet, where AI's ability to recognize patterns could unlock entirely new ways to solve complex problems.
Wow, that's really mind blowing when you think about it. It seems like this technology could have a huge impact on so many different fields.
Absolutely. And you know what's really exciting? The democratization of this technology. With many easy to use tools like TensorFlow and scikit-learn, even people without deep technical backgrounds can start experimenting with machine learning and classification. It's opening up a whole new world of possibilities for innovation.
That's really encouraging. So, if someone wanted to start learning about this, where would you recommend they begin?
Well, I'd say start by recognizing that you're already an expert at classification in many ways. Every time you decide whether to bring an umbrella based on the weather or choose which lane to use in traffic, you're using the same basic principles. The AI is just doing this on a larger scale with more variables. Understanding that connection makes the whole field more approachable.
That's such a helpful perspective. It really does make it feel less intimidating when you put it that way.
Exactly. And there are so many great resources out there now. Online courses from qubits.ai, tutorials, even interactive websites like Codebench, where you can play around with simple classification models. The key is to start small, maybe with a project that interests you personally, and build from there.
This has been so enlightening. Any final thoughts on the future of classification in AI?
Well, we're really just at the beginning of what's possible. As algorithms become more advanced and data sets grow richer, classification will be used in ways we can't even imagine yet. It's an exciting time to be learning about this technology, and the future holds so many possibilities. I can't wait to see how it continues to evolve and reshape the world around us.
Well, that's certainly given me a lot to think about. Thanks for breaking it all down for us.
My pleasure. And remember, classification isn't just something AI does. We do it all the time. Whether you're sorting laundry by color or deciding what to watch on Netflix, you're engaging in classification. We're all natural born classifiers. AI just takes it to the next level.
That is great to hear.
A big thank you to Jessica for sharing your insights, and thank you all for tuning in. See you in the next episode.